Good afternoon and welcome to the CTC MEP webinar. Today's webinar will be on Autodesk Inventor to Autodesk Revit. Okay, my name is Tim Gleniani and I am the Marketing Manager with CAD Technology Center. Just here to tell you a little bit about CTC. We are an Autodesk Gold Partner located in Minneapolis, Minnesota. Our expertise is in the AEC industry, but we also have a broad range of what we do as well. A little bit about us there on the screen. At the bottom there you can see our website, cadtechnologycenter.com. Take a look there. You can see our events page, view other webinars similar to this one, and see some other live events that we host on site and also in the community as well. Good place to view other webinars that we record and post up onto our YouTube channel there. YouTube.com CAD Technology Center is the channel. And also follow us on Twitter, CTC Bim, for great information for keeping up with what we do, events that are going on, and other information related. Your presenter today is Sid. He is our applications engineer, specializing in mechanical, electrical, and plumbing engineering. That I will kick it off to Sid, and he's going to start out with a poll. One thing I did want to mention real quick, we can toggle between audio on your computer speakers, or if you don't have that option, you can also dial in. You can toggle between the two in the webinar control panel up there, and there will be instructions to dial in, and be sure to use the PIN ID. Questions, if you have during the webinar, you can ask in the chat window on the control panel that will show up to the presenter, and we will address all questions at the end, so please stick around and we'll address each question, read them off so you can see what other people asked and listen in and get some more information there at the end. So with that, I'm going to hand it over to Sid, and he will begin the presentation.
Hello everyone, my name is Sid, and I'll be starting with the presentation. Now before we get started, I'd just like to do a quick poll to see the kind of audience that we have today. So the question here is, what kind of software do you use most often? Is it Inventor? Is most of your work in Revit? Or is it a mix of the two softwares? So feel free to vote in. Right, so the results so far says that we have about 89% of our audience in Revit and about 11% is a mix of both. Right, so I'll close the poll now and we'll continue with our presentation. So I'll try to tailor it more to the things you need to do in Inventor. Since most of our audience is green on the Inventor side, we'll see the kind of things you need to do in Inventor, and the Revit part of it we'll run fairly quickly through that process. Right, so here is a brief overview of the topics that we'll be looking at in today's seminar. We'll be going through editing and manipulating models in Inventor. We'll talk about the BIM tools in Inventor and describe their possibilities and a few limitations that they have. We'll then explain how the geometry and models are constrained and how they can be edited in the Revit environment. And we'll also in this process see how connector information is passed from Autodesk Inventor to Autodesk Revit. Now for those of you who are new to this entire process of going from Inventor to Revit, I'd just like to mention a brief background of how this process used to work in 2013 and earlier releases. So in earlier releases, the way you could go from Inventor to Revit is by exporting an Autodesk Exchange file. It's an ADSK file, and this file you could then open inside the family environment. Families are what are like components inside Revit, so your project is built using these families. So you could export an ADSK file from Inventor, and in the Revit side you could open that ADSK file in the family environment and save it as an RFA file or a Revit family file, and once that is done you could use it like any other family inside Revit. Now there was one drawback to this process in the sense that when you export it out from Inventor, you would just get a 3D block in Revit, and the process of exporting itself would involve simplifying the model. So when you simplify the model, there are certain pieces of the element that get deleted that are not really in the user's control. So you may have to do some more modeling inside Revit before you can actually use it in your projects. So they've taken a very big step in that process and made things a little more smoother now. There are limitations which we'll see as we go along. So the first example we'll be looking at today is an expansion tank. So this is an expansion tank that I got from a certain manufacturer, and these are some of the basic dimensions for this expansion tank that we'll try to model in Inventor and try to bring that into Revit. There are different sizes for this expansion tank, and we'll see how we can make it parametric in the Revit environment so that we can use it just like we use parametric Revit families. So with that, what I'll do is I'll switch to my Inventor software and I'll go to open that file. So when I click on open, I can browse to the file I want to bring in, and I have a folder here, and I can choose the file type that I want to bring in. I'll set this to bring in files of all types, and I have a step file that was a 3ds Max file, so I can select that file and open it up. And this is basically how that expansion tank shows up. Now as you can see here, this expansion tank is composed of 3 solid objects. So you've got these 3 solid objects that make up this expansion tank. So to convert this to a part that can be recognized by Revit, the place where you start is the Bim tab. So they've given you a brand new tab in Inventor, and it's got these 3 buttons which we'll look at. So the first place you will typically start is by checking Revit features. So what this is going to do is it will take you to an HTML report page like this description tells you, and it will generate a report on all the parts that can be recognized by Revit. So I'll hit that button first, and right away it tells me that all the 3 base features would fail to export if I try to export it at this point. So it's telling me that it's not a supported Revit family file, and it gives me a tip to enter the BIM feature recognize environment to then represent my model with features that would be recognized by Revit. So we'll go back in the Inventor environment, and I'll start on the recognize Revit feature. And here you've got some buttons here that you can use to recognize features and simplify the geometry before you push it out to Revit. So we'll start by clicking on recognize revolve, and I can click on any surface for that expansion tank body, and it will highlight it with this color, and it will allow me to then accept this as a revolve. So if I hit OK at this point, that solid 2 got pushed from the expansion tank part file to a new feature now, and it's also not visible in my window here. So I'll recognize that one feature. I can also go to recognize extrude and recognize this little portion here as an extrude feature, and it will also add that here in my browser over here. What I can further do is I can try to export this little screw up here. Now if I try to export this, what will happen is it's not a feature that will be recognized by Revit. So what we'd have to do is we'd have to go to remove details to remove certain faces out of this little screw. So it removes fillets, chamfers or other custom selected faces, and so I can start by clicking on remove details, and when you do that you can see that it doesn't highlight any face. So to see those faces you need to make sure that the all faces selectable option is checked, and with that option checked, what I can do is I can then select these faces that I want to remove. So I'll just orbit around this model, make sure I grab these faces, Okay, so we'll continue selecting those faces that we want to get rid of. So at the end of that, I should have about 12 faces selected, 6 at the bottom, 6 at the top, and then I can hit finish, and then it simplifies the model without those faces. What I can further do is I can click on define envelopes. So when I do that, it will allow me to define the geometry with simple cylinders or boxes or cubes. So when you select a face, it's going to automatically come up with this bounding box. Now you can go from a bounding box to a bounding cylinder depending on the kind of geometry you want to use, and you also have options to resize it. Okay, you have options to resize it, and you can either choose to join this feature to the existing feature or define a new feature. So we'll go with new feature, and I can click on resize, and it gives me these arrow grips that I can use to control the size of that cylinder. So if I click on one of these arrows, it tells me the size of that extrusion. Now it's set to a value of 0.3333, and we'll just make a note, a mental note of this dimension. Okay, because there is no way we can actually assign that to a parameter at this point. So I'll go to define envelopes, select that, make sure cylinder is selected. I'll go to new feature, go to resize, and I'll just make a note of the depth of that extrusion, and at that point I can hit this mark and define that as a revolution. So you'll see that show up also in the new feature. And similarly, I'll go to define envelopes, select the stop face, and again make sure the bounding cylinder is checked, and I have a new feature, and I can go to resize and grab this grip and move it down. Now I want this face to go all the way down to this face, and to do that you see the align tool available now. So I can click on that and I can align it to this face, and then I know that this extrusion is going to go all the way down. Okay, again we'll make a note of this dimension, and I'll just hit the green check mark to finish that extrusion. So it's going to define that as an extrusion, and once I have these pieces of geometry recognized, I can also go down here and we have this little portion now that we need to recognize. Now note that if I go to define envelopes, or if I actually start by going to recognize revolve and try to recognize this as a revolve feature, it shows me this check mark to mark this as a revolve feature, but when I select it, it tells me that the revolve feature was not successfully recognized. Okay, so this is another thing that you will have to handle on a case-by-case basis. So there will be some families for which it will recognize the feature instantly, and some other families for which it may not quite do that. So what I'll have to do is go to define envelopes and select this face, and now I'll go to resize, grab the arrow, move it up, and I can select align and align it all the way up to that face. And when I do this, it is not going to mark a new feature here, which we'll see now. So it doesn't create a new feature there. So even though we defined the envelope, it doesn't define that as a new feature. So what we'll do at this point is, with the features that we have so far, I'll hit finish recognize, and it takes me back to the main page. Now in this window, if I try to do the check Revit features again, we'll see that the 4 features that we created would successfully go to Revit, but the base 4 and base 5 features will not go out. So let's go back to the Inventor environment, and base 5 is the piece at the bottom, and base 4 is the piece at the bottom, and base 5 is the piece at the top. So this piece I can completely suppress because we already have a representation for it. So I can right click and just select suppress feature, and it suppresses that feature, and we just see the extrude features that we created. So now what I'll do is also go to the manage tab, and you'll see the parameters here, and the dimensions for those extrusions will be visible over here as parameters. So the depth that we had for the connector, which is the portion at the top, we can assign it a variable and call it connector height. And then this variable D3, I can call it as the base connector height. Okay, so we can define these variables and I can hit done. So the importance of defining these variables is if you do not do this, when you bring it into Revit and you go to the family types dialog box, it will list all of these dimensions with the same name there. So it makes it a little difficult to recognize these dimensions in Revit if you do not rename them at this point. Okay, so that's a slight limitation that you have to work around at this point. So to recognize the base 4 feature, what we'll do is we'll go back to BIM and I'll go to recognize Revit features again, and you then get the option to choose to either keep features recognized by Revit and they will be hidden while recognizing additional features, or convert existing features to base solids before recognizing Revit features. So I'll go with the default option, which is the first one, and hit OK. And now it hides everything except that small little piece at the bottom. So to define this as a revolve, what I can do is I can go to define envelopes and I can note that we just have solid 5 here. So I can select this face, go to resize, grab this grip, move it down, select align, and I can align it with the bottom face. And again, we'll just make a note of the dimension value here. Okay, we can assign that also to a variable, and we are using a bounding cylinder, creating a new feature, and I can then hit the green check mark to finish that, and now it is recognizing this as a new feature. So now I can hit finish recognize Revit features again, and what I can now do is, since we have that bottom piece also recognized by an extrusion, I can suppress this feature as well. So I'll right click, suppress features, and now I can click on check Revit features again, and at that point it will tell me that all the features passed the check successfully. So I can hit OK at this point, and once you have recognized all the features you want to use, the next step is when you go to BIM Exchange. So you start here, go to recognize Revit features, and then go to BIM Exchange. So when you go to BIM Exchange, this is very similar to how you would have seen it in 2013. This is where you can define connectors for the expansion tank, and we'll see how that connector information gets passed along. Okay, another point to mention here is if I go back to manage and go to parameters, notice that the parameters that we defined here just get erased when I go back to that recognize Revit feature dialog box. So this again is a major limitation. So it's recommended that you make a note of these dimensions and assign variables to them at the end of that recognize Revit feature process, so that you don't have to go back in there and define labels for these variables again. So I'll call this connector height. Okay, Inventor doesn't like spaces, so you need to make sure that you use an underscore there. I can select this and call this the base connector height. And I can select this dimension, or it was actually this one, 0.63125, and I can call this the bottom extrusion. Bottom extrusion height. And I can also have one for the little stub at the bottom, and I can just call this bottom stub height. What we can also do is we can define numeric parameters here. So I'll add a numeric parameter, it marks that as a user parameter, and I can call this connector diameter. So this will be useful when we define our connector. You can call this connector dia, and I can set it to be at a value of 0.5 inches. Okay, so I do that and I can hit done, and back inside the BIM Exchange we can start by creating a pipe connector. So I'll go to pipe connector and I can select the face where I want this connector to be created, and you can click on this for the size, and the diameter now can be controlled by the connector diameter parameter that we just created. Okay, same for the nominal diameter. The system, I can set it to be hydronic supply, and then it shows me all the properties that you would see for the connector when you open or select this connector in Revit. So the system or the flow configuration, I can set it to be at system so that it inherits the properties for the system it's connected to. And the flow direction, we can set it to be bidirectional, and then I can add a description for this also and maybe call this expansion tank connector. Again, these are the same fields that you would see for the connector when you select it in Revit. And for those of you who are not from the Revit world, the connector direction that you see here is not the direction of the flow. It in fact is the direction in which Revit expects the connector to connect to a pipe. So it would expect you to connect to a pipe starting from the tank to the main run rather than going from the main run to the tank. So that is what this direction indicates. And I can hit OK at this point, and I have defined the connector. The next thing I can do is I can click on check design, and it gives me a few more parameters and information about this model. So it tells me the connector, it tells me the overall dimensions, right? It tells me that there's no classification for this at this point, which we'll do in a minute. Okay, I can check Revit features again, and it should tell me that the Revit features have passed. And finally, I can go to export building components. You can also define a UCS, and then that will be the insertion point for that family when you bring it inside a project. So I can go to export building components, and it will first require me to save this before I export it out. So I'll hit OK, and it will save that file. And now you can choose the kind of orientation you want it to use. You can go with the view cube orientation, or in this case I'll select model origin so that I have it oriented this way. You can either export an RFA file, or like you would do previously, you can also export an ADSK or an Autodesk Exchange file. You can click on this button here and set a classification for this. So I can type in expansion tank, I can search for that category, and when I search for that, not only is it going to assign an Omni class number and title, it's also going to assign a Revit category to that item. Okay, so it will come in with the right category depending on the way you classify it over here. So I can go with expansion vessels, it will classify it as a mechanical equipment inside Revit, and I hit OK. What you can further do is you can check model property, and it will automatically add some model properties that are representative of this model. So I can click on model property filter, and you can either set it to use properties with values, or you can click on this radio button and then specifically choose the properties you want the family to have. So I can additionally make sure that it has all these physical parameters also added. So I can hit OK, and then I will see those physical properties like the center of gravity, density, material volume, and so on also added for this family. And I can then hit OK and choose a location for this family. I can save it to my desktop, and I can hit save. So when I do that, it's going to go through that process, and if you've done this in 2013, you will see this window to be a little familiar, where it exports this family out, and it also creates a report. So I can select yes here to view the translation report, and it tells me that it has pushed out 5 features and 1 connector. Okay, everything has gone out successfully. Connector has also gone out, and I also see these Inventor parameters that have gone out. Okay, so at this point what we can do is we can open that family in Revit and see how that family exactly looks in our Revit environment. So in the Revit environment, what we can do is we can go to open family, and I can browse to the desktop and make sure I select the expansion tank. One thing to make note of is the file size. So you can see that this file size is quite reasonable for a Revit family that you would create natively. So I can select that family and hit open, and it opens that family up in my Revit environment. I can look at it in a 3D view, and this is how it comes in with the connector information. Okay, I'll turn my thin lines on, and I'll start on the reference level. Now I can go to the family types and see all the parameters that we had created in Inventor. They've all come through here. Okay, so you'll also see the model properties. And what I'm now going to do is I'm going to assign a radius that will work with the connector diameter so that the connector flexes the way we would want it in Revit. So to do that, what I can do is I can zoom in here and I have the connector selected. I can hit the tab key and it then highlights the extrusion for the connector, and now I can hit my left mouse button and it selects that extrusion. So I can now go to edit extrusion, and what I can do is I can select that dimension and I can unlock these constraints here, and I can make this temporary dimension a permanent dimension. So with that done, you can select that dimension and you can assign a label to it. So I'll go to label, go to add parameter, and I'll call this connector radius. Okay, we'll define it as a type parameter and I'll hit OK at this point. Okay, it gives me a warning at this point and it tells me that the dimension had to be unlocked in order to remove sketch over constraining. Okay, so we'll accept that warning. And what we'll also do is we'll edit or exit out of that extrusion. So now I can flex the connector and see if it flexes fine. So I can go to family types again, and I can say that my connector radius is nothing but my connector 1 diameter by 2. So I'll define this formula. Okay, so instead of being at ½ inch, let's say we want to also have a 1 inch, because that is also one of the diameters we have set up for the types. So let's just see if that would work, and I hit apply, and the connector and the extrusion both flex as we would expect it to. So I'll set it back to 0.5 and I'll hit OK. Now I can go to a front view and further see how this model is being constrained. So here are those dimensions that we had defined, and before we go ahead, what I'll do is I'll just select that dimension, go to edit type, and I'll change the text size so that the dimensions are a bit more legible. So I'll do that, set it to a 1/64, and then I can grab this dimension label and then just move it out so that we see the dimensions that came in from Inventor. Okay, so we have our dimensions over here. Just line them up, and to make this a flexible family so that we can use it the way we would use families in Revit, what we need to do is add some additional dimensions to constrain it. So we'll start on the annotate tab, go to aligned, and it creates these reference lines. So I can go between this reference line and this reference line and constrain it over here. I'll hit escape a couple of times, select this, and now we know that this dimension is the dimension B. So if I go back, B is the overall diameter, so this dimension would typically be B by 2. So I can go to add parameter, call this B by 2, set it to be a type parameter and hit OK. And now if I go to family types and I try to flex it, so one size is a 4 inch and the other size is a 5.5 inch. So you see this is what it's doing. So what we need to do is also constrain the bottom portion of that extrusion. So I'll set it back to 4 and hit OK, and I'll go to annotate and add another dimension this way, and I'll place it at the bottom, and this dimension also I will assign it to B by 2. Okay, so now that dimension should at least flex fine. The next dimension we need to create is the dimension A. So to create this dimension, I'll again go to annotate, go to aligned, and I'll add the dimension between. So if you go back in here, you see that this dimension is going from this bottom point to the top point. So we'll go in a similar way. Now I need to make sure I pick the reference point corresponding to this reference line. So I'll hit tab a few times and it selects the reference point corresponding to the reference line, and I can tab and select the reference plane at the top and place this dimension, and I'll hit escape a couple of times. Now I can select this dimension and assign a label to it and call this A. Okay, so we have A, we have B, and what I can do is now go to family types and just flex these dimensions also. What in fact I can also do is define another parameter B and then say that B by 2 is going to be controlled by B. So I'll go to add, define a new parameter called b, assign a value of say 8 inches, and I'll say that b by 2 is in fact b by 2. So if I set b to be say 11 inches, which is for the second type, that should flex fine, right? And then I can set a to maybe at 1 feet, that is what we have for type 1, and it gives me this message saying that constraints are not satisfied. So I'll cancel that and leave this default. So to constrain it properly, what we also need to do is add another dimension between these reference planes. So I'll go to annotate, go to aligned, and I'll add a dimension between these two reference planes, and I can label it and call it say X. Okay. Further, what I can do is I can control X and say that X is in some way controlled by the parameter A. So I can define this parameter, and now if I set its value to be at 1 feet, it flexes fine, and I can hit OK. Now notice how this bottom portion has moved down. So to control that, what we can do is again go to modify, and we'll select align this time, and we'll just align and lock these reference planes so that that little portion also stays with the family. So we can now go back in here and define all the types for this family, just like we have the types from the manufacturer. So the first type, and I have this printed out right in front of me, and I'll just type these values for the different types we have. So the first type is going to be a 1 by 8 for A and B. Hit apply. I can define a new type, and for this type the sizes we have are 15 by 11. Hit apply, flex it, see it's flexing fine. Define a third type, and this can be say a 23 by 11 again, flexes fine. Define a fourth type, set it to be a 21 by 15. Okay, and then just flex to see if it works fine. Go to a type 5, which is a 24 by 15. Define a sixth type, which is going to be a 32 by 15. That flexes fine. In fact, type 6 has a different pipe diameter, so this will go from a 1/2 inch to a 1 inch. So I can change that also and see how that extrusion and the diameter change accordingly. And I can define my seventh type to be at 32 by 18 inch. Okay, with a 1 inch diameter. So I can define my family in this way, and what you can also do is save this family, and for families that have more than 6 types, Autodesk recommends that you use a type catalog. So we can also generate a type catalog automatically for this family by going into export and selecting family types. So it exports a type catalog, and for those of you who are in Revit, you would be familiar with this concept that the type catalog needs to have the same exact name and the same exact location as the family for it to work when you pull it inside a project. So we'll save this also to the desktop with the same name, and at that point what we can do is test this family inside a project. So I'll start with a mechanical template and create a new project, and in here what I can do is I can go to insert tab, go to load family, and I can go to the desktop and look for this family. So that's the backup. This is the actual family, and when I bring it in, it brings in all my types. Let's say we just need all of the types. Okay, so the benefit of type catalogs is it helps improve model performance by allowing you to select only the types that you want to use in your project. So if you're going to have some 30 or 40 odd types for some family, you need not load all of them in the project. So that way it will allow you to keep the file size to a minimum and will improve the performance. So that's one benefit of using your type catalog. So in this case we'll select all the types, hit OK, it brings all of them in, and now I can go to the Systems tab, select Component, and start placing my types in the project. So I'll start with type 1, so we forgot to rename that, which is fine. Place type 2, place type 3, type 4, type 5 comes in over here, 6, and type 7. Okay, so we have all the types placed, and I can maybe also go to a 3D view to see how these expansion tanks show up. Okay, so you can go to a 3D view, and you can also maybe orient it to one of the orthographic views. So that's how all your tanks would show up in the project. Now if I try to route a pipe to it, that should also work fine. So I can go to pipe, say I start at 6-inch offset with a diameter of say 2 inches. I can start over here, make sure it's hydronic supply because that's how we've defined the connector. And I can also go down to this tank. Okay, so you should see that also in your 3D views, and it should propagate the flow and also do the calculations correctly. So basically that's how you can go about creating families from Inventor and bring them into Revit. Now what we've looked at so far is an example of a part file. Now you could also get something like an assembly file which could be made up of all of these different parts. So to see that example, what I have is an example of a furniture piece. So I'll hit finish BIM exchange and I'll go to open, and suppose that you get this piece of rack or furniture from some manufacturer and you need to bring that into Revit. So we'll open this model, and now once you're in the assembly environment, notice that you do not see the BIM tool anywhere. Okay, so from the assembly environment, if you want to go to the part environment, you need to do a few things before you can go through that process. So we'll start on the simplify tab, and this is where you can go again from left to right, and you can choose the components that you want to include for your BIM exchange. So I can go to include components, and suppose if you want just this portion and this portion, you can just select those components. Now in our example, let's assume I want everything to be visible in Revit, so I can select all of them and I can hit the green check mark to select or include all of these components. Once they are included, what I can do is I can go to define envelopes, and this is the same that was also available in the BIM environment for the part. So we'll have the bounding box selected, and I can select this part, and the material can be set over here. Okay, so I can set it to say some form of wood. So I'll go with say white oak as a material for this. So it will assign that material. Okay, so similarly material can be assigned to all of them. We'll just skip that part, and we'll just define envelopes for all of these pieces. So I can select this piece now, and instead of a bounding box, I'll go with a bounding cylinder, go with the default material, and it'll do that for all of those parts. Select, go to define envelopes, select this part, set it to be a bounding box again. Okay, go to define envelopes, select the bottom piece, set it to be a bounding cylinder. Okay, now there are a few more pieces that we need to define. So this piece, for example, doesn't need to go all the way up, so I can grab the grip at the bottom and move it up, and then I can select a line and move it to the bottom face this way and hit finish. So it does that for all of these pieces up here. And we also have some pieces down here that we need to define. So I'll go to define envelopes, select that, grab this grip, move it down, select a line and align it to the bottom face. Select the grip at the bottom, move it up and align, select a line and align it to the bottom face this way. So now we have all the pieces defined. There's another piece at the bottom that needs to be defined. So I'll select this, move this down, go to align, align it this way and hit finish. So you need to do some work in the assembly environment, And once that is done, what you can do is go to create simplified part. Now before we do that, just another way to assign material is by selecting it and clicking on the material drop down and assigning materials to your parts. That is a preferred way if you assign materials in Inventor. Now before I create that simplified part, it requires that I save this. So I'll save it, say, again on my desktop. I'll say yes to all of its dependents and then hit OK. Okay, so once we've saved that, I can now click on create simplified part, and it's now going to create a simplified part and take me to the part environment. Now before you do that, you have these different options here. You can either combine them into a single body with seams between planar faces merged, or you can combine it as a single body with those planar faces maintained, or you can maintain each solid as a separate body. We'll go with that option. This is the name, and I'll save it, say, again to my desktop. And I can hit OK at this point, and it's going to save that as a part file and take me to the part environment. So once I'm inside the part environment, the process that we follow for creating this as a Revit recognizable part would be the same. Okay, so at this point, since most of the work we did was in the assembly environment, I can simply again start with check Revit features, and it's going to check all the features there. And once that is done, since we did most of the work in the assembly environment, it tells me here that all the features have passed the check successfully. So at this point I can simply go to Bim Exchange, and there are no connectors that I need to add here. I can just simply go to export building components. Let's save this, hit yes to all, and you can define the model origin to be at, say, this corner for the family. Okay, you can obviously add these parameters here, and they will also get transported to your Revit family. And now I can also assign a category to this. I can select furniture and assign it to be a residential furniture. It will set it to be a furniture category inside Revit, and I can do that, hit OK, choose where I want to save this file. Let's say I save it to the desktop, and it's again going to do that self-documenting process where it will generate a report and show us the parts that were able to go out and the parts that could not. Okay, so depending on how complex the family gets, the process could take a little longer. Now we have a question here. In the time that this goes out, I can just try and answer that question. So the question is the shrink wrap tool available in the base model of Inventor? Seems to be a lot easier to export an overall solid mass versus setting up multiple parameters of an object or model before exporting. So far I have not been able to discover the shrink wrap tool. I think they have completely replaced that tool with these new set of tools. And the shrink wrap, although it would automate the process, there were limitations. Like I had this experience where I had to export a pump out, and it did not do a very good job of pushing all those pieces out. So there are limitations to that process. So it comes down to the kind of file you are looking at. You really have to treat it on a case-by-case basis and then decide if shrink wrap might be a faster route, or setting it up with parameters would be a better route, because setting it up with parameters obviously will allow you to make it a parametric family in Revit. So there are benefits to this route as well. So we can now view that report, and we see that 100 features have been successfully exported. Okay, if I scroll down in that report and look at the Inventor Parameters, it will also push out all of these parameters. Okay, now these parameters got defined when we were defining those envelopes for the model. Okay, so when I open this family up inside Revit, in the family types you will find all of those parameters as well. So I can select this family, hit open, and it shows this family. I can go to a 3D view. Okay, and if I go to family types, I'll see all of those parameters there. So this again is a limitation that you have to work around, and be careful that you define these by labels if you want it to be parametric, or else just accept this list of dimensions that it will throw in your Revit family. If I go to family types, you'll also see that it's classified as a furniture piece, and I can go to a realistic view, and you'll see that the material that we assigned came in the sense that it has that representation, but when I select it and look at the material, it's assigned by category to that. Okay, so the material also comes in this way. Okay, and of course you can push it inside your project and use it in your projects. So this process, if it's just a single piece that you're bringing in, might be a lot faster than creating that family in Revit. So you can see that insertion point there, and I can place it there, go to a 3D view, and I'll see that piece over here as well. So any other questions, comments, suggestions? Okay, so to review what we've looked at today, we saw how you can edit and manipulate models in Inventor. We saw how the Bim tools can be used. We looked at some of their limitations, for example the dimensions coming through, and also the material. To an extent you can't parameterize it, and you can see how the geometry and models are constrained and how they were being edited in Revit, and we saw how the connector information came from Inventor to Revit. Okay, so with that I'd like to hand it over to Tim.
All right, everyone. Thank you for attending our webinar today. Appreciate you coming by. Immediately closing your GoToWebinar window, it will ask you for to take a brief survey. It'll automatically open up in your default web browser. This is a new system to us using GoToWebinar. We'd really appreciate your feedback and letting us know how it went, the quality of the audio system, the ease of use in the control panel, and then also tell us a little bit about the presenter and the content you saw today. It's also a good place to let us know if there's any other information you want to see conveyed in a webinar. We're always looking for new ideas. We always want to keep you guys informed on what you want to hear. So it's a good place to communicate that to us, and we'll look into getting it into a future webinar. Also wanted to mention that this topic that you saw today, along with many others that Sid can cover, he's our MEP expert, like I said, and we also offer classroom training in person. We have a training center on site here in our Minneapolis office. We also have an office in Des Moines, Iowa, that we can do classroom training. We understand that not everybody is on the same level with Revit or the software that you use, so we can always do customized training and treat your needs. If there's anything else you want to see, we can also do a webcast. If you're not around the Midwest, if it's too far for you to travel, we can always customize something and do webcast training online, similar to what you were viewing today, only it would be more interactive and two-way communication. So again, please take the time. There's only 6 questions in the survey. Probably take you less than 30 seconds, and that information is very valuable to us. We appreciate you coming by today, and have a good rest of your afternoon.